The effect of outliers on the correlation coefficient. Outliers can have a very big effect on the value of R, the correlation coefficient. This can occur either by hiding a strong correlation or making a weak correlation look strong. So let's first of all have a look at outliers hiding a strong correlation. Consider the two sets of data shown below, A and B. So here we have set A and here we have set B. They are the same, they're the exact same, except that B contains one extra point. So we can see this extra point here, point P. This is the only extra point in B, otherwise the two sets are the exact same. So this is the outlier and it's labelled P. So this is the outlier in set B. However, the difference in the values of R is very significant. So R is equal to 0.89 for set A, quite close to 1, and R is equal to 0.21 for set B, much closer to 0. The data represented in A shows strong correlation. 0.89, again, quite close to 1. So the closer you are to 1, the stronger the correlation. While that in B shows weak correlation. So again, the correlation coefficient is closer to 0, and the closer you are to 0, the weaker the correlation. But we can clearly see that both sets of data are very, very similar. But this outlier P in set B is bringing down the correlation coefficient. So it's down at 0.21, close enough to 0, whereas R, or the correlation coefficient for set A, is quite close to 1. Outliers making a weak correlation look strong. Consider the two sets of data shown below, C and D. So set C and set D. Again, they are the same except that D contains one extra point, the outlier labelled P. So we can see that these data values are in the exact same place for C and D, but set D has this outlier of P. Again, the difference in the R values is very significant. So the difference in the correlation coefficient is very different. So we can see R is equal to 0.18 for set C. So it's close enough to 0. So there's very, very little correlation. Whereas for set D, R is equal to 0.82. So it's much closer to 1. So this is showing a very strong correlation. The data in C shows very weak positive correlation. So it's very weak because it's quite close to 0. But the extra point in P causes the correlation to become very strong. So 0.82, it's quite close to 1. Outliers can have a big effect on the correlation, but they don't have to. If, for example, there is a very strong correlation and the outlier lies close to the line of best fit of the data minus the outlier, then the outlier will have little or no effect on the correlation. So, how to deal with outliers is the subject of much debate. All seem to agree that if the outlier is as a result of some error, then it should be removed. However, if the outlier legitimately belongs to the data, then most feel that it should not be removed, even if this appears to distort the analysis of the rest of the data.